Welcome back to Natural Language Processing. The next lecture is going to be on one of the most interesting areas of natural language processing, specifically question answering. So you're all familiar with question answering from different apps and websites and probably from television. One of the most popular applications of question answering is in speech systems like Siri that was created by Apple. So here's an interface snapshot for Siri. You can ask it a question, whether in text or in speech, as for example, what is the population of Sri Lanka? And then it gives you an answer, 20.4 million people. There are many other websites and systems that deal with question answering using natural language processing. One of the most popular ones is called Ask Jeeves, formerly. Now it's more known as ask.com. So this is a website that allows you to ask questions in natural language form. For example, who played Linus in Lost? And then it gives you some information about the person. So the Ask Jeeves is somewhere between a standard search engine in that it returns mostly documents and a pure question answering system, because it still allows you to ask the questions in the form of natural language questions. Another example is Wolfram Alpha, which is used for mathematical computations, again in the form of natural language dialogue. So you can ask a question such as, what is the area of a circle with radius 5 feet? And then it will give you the answer, and it will also give you some mathematical derivation and an image that shows you how the answer, which is 25 pi square feet, was computed. And probably the most famous and at least the most relevant to this class is IBM's Watson system. So a little bit of background, IBM's Watson system is a question answering system that was used on television to play in the Jeopardy game in the beginning of 2011. So this is a snapshot from the TV show. It shows the two best humans that time who were facing against Watson. Watson is not really embodied here at all. It's just represented by its avatar, which is the logo with a globe and the form of some sort of a light bulb. And as you can see from the snapshot, after the final question of this round of Jeopardy, Watson was ahead by a huge margin, $77,000, compared to the two humans who were way, way behind. So how did Watson do on Jeopardy? Here's some sample questions. For example, on December 8th, 2008, this national newspaper raised its newsstand price by 25 cents to $1. So this is a very typical question for Jeopardy. It's formulated slightly differently from traditional questions in that it's really formulated as an answer, and you're supposed to answer using a question. So in this case, you would suppose to say something like, what is USA Today, which is the name of the newspaper. I should notice that the question and answer format used in Jeopardy is really equivalent to normal question answer. It's just a little twist that is added to formulate the questions and the answers in the opposite order. So here's some other questions that were used in the actual Jeopardy round. In 2010, this former First Lady published a memoir, Spoken from the Heart. And you're supposed to answer, who is Laura Bush? And then some other questions that you can look at on your own. All of those were given in the competition between Watson and the two human participants in 2011. You can see some Watson videos on your own. Here's some that I recommend. They're all available on YouTube and other external websites. So why do we want to care about question answering in a natural language processing class? Well, first of all, because people ask questions online. If you analyze some large corpus of queries in search engines, you will realize that many of the queries are in the form of natural language questions. So one of the earliest analyses of query corpora was of the so-called Excite corpus, which had 2.5 million queries, about 1 day's worth. And simple analysis showed that about 8% of those were in the form of natural language questions. Even though the search engine was not really supposed to understand natural language questions. So that means that users are expecting the search engine to understand human language questions, even though it's not officially designated for that. So of those 8%, about half were factual questions. For example, what is the country code for Belgium? And the rest were procedural. For example, how to get out of debt or other types of questions. Now, I should notice here that factual questions are much easier to deal with than procedural questions, because procedural questions require a lot of context. For example, who is the user, what sort of background they have, whereas factual questions typically have a single answer that may vary over time, but in general, it's a single answer or perhaps one of a small set of possible answers that are much easier to find. So here's some questions from the Excite corpus. In what year did baseball become an official sport? Again, this is a fairly straightforward question. The assumption here obviously is that this is about the United States. If this question were asked in a different country, perhaps the answer would be different. How do I get out of debt? I mentioned this one already. And here's some others. For example, when is the Super Bowl? Well, as I mentioned before, questions of this type have multiple answers that depend on time. So this year's Super Bowl is in a couple of weeks. Next year's Super Bowl is going to be in a different location on a different date. So the answer to this question will vary depending on when it is asked. Same thing goes for the next question. Who is California's district state senator? It's completely possible that the answer to this question depends on the location, and it certainly depends on the time. Here's some more sets of questions from different systems. So one of those systems is called Murax. It was one of the first research systems that was built in the mid-90s by Julian Kupiec of Xerox PARC. And it was supposed to answer questions based on a large encyclopedia. So some questions that are appropriate for this kind of system are of this nature. What US cities at the junction of the Allegheny and Monongahela rivers? Who wrote Across the River and Into the Trees? Who married actress Nancy Davis? And so on. As you can see, those are fairly factual questions, and they are specifically related to the corpus, in this case, an encyclopedia in English. Okay, so a few more examples of corpora of questions that have been published. One is the so-called AOL corpus that was published about 10 years ago. And again, you can see that people ask very different types of questions. For example, what does cerebrocortical atrophy mean? What fraction is closest to pi? What is the highest calories consumed by a person in a 24-hour period? You can notice that some of those questions are mistyped, and this is very common in query logs. People don't always ask the questions in the most grammatical way possible. So a few more, you can look at them on your own. So one thing that people in research in natural language processing do for question answering is called question type taxonomy. So they want to build an ontology of question types so that systems for question answering can be built more efficiently. So what are the question types? Well, there are different distinctions that can be made. One distinction is between the so-called yes or no questions, which require, as the name says, either a yes or no answer. For example, is Barack Obama the president of the United States? Yes or no? So those are contrasted with the so-called WH questions. The WH questions are who, what, where, how, and so on. Another distinction is between factual and procedural questions. So factual questions require usually a short single answer that's factually based. Procedural questions usually require a lot of understanding about the context and the user, and typically require a much more sophisticated and detailed answer. A third dimension is between single answer and multiple answer questions. So for example, if I ask what's the state flower of Oklahoma, I'll get one answer. But if I ask a question, for example, who are the representatives from the state of Oklahoma, I will have to get, by definition, multiple answers. So if I ask which states were the first to sign the US Constitution, again, I will get multiple answers. Another dimension is between objective and subjective questions. So for example, if you ask which movie won the Golden Globe, you will get an objective answer, versus if you ask what was the best movie of the year, you're probably going to get a subjective answer. I should note that both of those are legitimate types of questions and questions that people ask, people that expect to get answers from a search engine for. However, the ways that systems deal with those questions can be very different. One more dimension is about context-specific and generic questions. So a generic question may be something that doesn't depend on the user or their background or the type of queries that they've asked most recently, whereas a generic question would be the opposite. Another dimension is whether there is a known answer in the collection, yes or no. So in many research evaluations of question answering, it was assumed that all of the questions that were used in the evaluation had an answer somewhere in the collection. So the question was, can you find this answer, perhaps the sentence that contains it? Now, in the more general case, the answer to a question is not necessarily in the collection. So you should be able to say, I don't think that there is an answer to this question in the collection. And you would get points if you correctly say that there is no answer. And you would lose points if you think that there is no answer, but in fact there is one. So what's the state of the art in question answering? So most of the work is on factual and short answer questions. The system architectures typically include the following components: an IR component. So if you have a question, it's converted to a query for a search engine, and then the search engine returns documents that are likely to contain the answers to those questions. Most current systems use statistical approaches with lots of data, in some cases terabytes. They use relatively little knowledge in the sense that they don't have detailed inference procedures and detailed knowledge representation. They use mostly surface patterns. So now I'm going to go ahead and give you an overview of some of the systems that have been built over the years in question answering. And I'm going to start with the oldest systems out there. And the way that I'm going to define oldest is that those precede the so-called TREC evaluation. The TREC evaluation happened in 1999 and has been going on for quite a few years since then. So let's start with those old systems now. Perhaps the first system that relates to question answering is the so-called baseball system, which was built very long time ago in the 1960s. Its domain was questions about the baseball statistics, and it had a very small vocabulary and very small set of questions that it could answer. A second system, which is only marginally classified as a question answering system, is ELIZA, which was introduced by Weizenbaum in the mid-60s. It was a dialogue agent that simulates the use of a psychologist, a therapist. The third one that I would like to discuss in more detail in a few minutes is Shrdlu, which was built by Terry Winograd in the early 70s. That one had to deal with questions about the simulated world of blocks. So you had red blocks and green blocks and square blocks and round blocks, and the system was able to manipulate that world by putting blocks on top of each other and by asking and answering questions about them. The next system that I would like to mention is a system created by Bill Woods in the early 70s. That system is called Lunar, and it was based on data from expeditions to the moon that returned with a large collection of lunar rocks. So the questions that you could ask there were, for example, how many rocks have such and such property, and so on. I will give you some more detail about those systems in the next few slides. So the first more general domain system for question answering was introduced by Julian Kupiec in 1993. It was based on an encyclopedia, it was open domain, and I already showed you some of the questions that it was able to handle a few minutes ago. The first web-based system was called START. It was designed by Boris Katz at MIT in the mid-90s. It was completely open domain, and it used the web corpus as the backend. And then I'm going to mention very briefly a few more systems. For example, the system called Deep Red from MITRE, Lynette Hirschman et al. 1999, which was used for answering reading comprehension questions about school-level texts. And I would like to mention also one of the first spoken question answering systems by Victor Zhu and his group also at MIT in late 90s, early 2000s, called Jupyter. So let's now look at some of those systems in a little bit more detail. I mentioned that ELIZA was not really a question answering system, but I would like to mention it here because it's still engaged in dialogue and it was very influential in the development of future dialogue systems. So it plays a therapist and doesn't really answer any questions. Again, this is a little joke on therapists. So maybe if you go to a therapist and you ask a question, they don't really come up with answers. They just ask you some further questions and ask you to think about your problems more. It uses very simple pattern matching, and then it converts some of the questions that the user asks into further questions, or it asks for clarifications. So for example, let's look at this following dialogue. ELIZA says, I'm the psychotherapist, please describe your problems. And then the user says, I'm always tired. And then the system says, why do you say you're always tired? Again, it doesn't really give you any useful information. It just asks you some additional questions. Because I cannot sleep. Is it because you cannot sleep that you came to me? So it has a way to convert, some of the surface patterns of the user's questions into additional questions, follow-up questions that seem to indicate some sort of intelligence, even though it's really not there. Yes, help me, please. And then at this point, the system doesn't know what to do, so it starts again a new thread in the dialogue by reminding the user of something that they said earlier. Earlier, you said you cannot sleep, and so on. So the next system is Lunar. Lunar stands for Lunar Sciences Natural Language Information System. It was based on a collection of moon rocks returned to Earth by Apollo 11. So Lunar was able to ask questions in English about this very restricted domain. It included the following components. The first component was a general purpose augmented transition network grammar for English, or an ATN grammar. An ATN is essentially a finite state machine with some transitions that are labeled so that you can jump from one section of the finite state machine to another. And then it uses a procedural semantics framework for semantic interpretation. So it's able to convert syntactic information from the question into some sort of a semantic representation that is specific to the domain. It maps the questions to a logical representation, and it uses a 3,500-word dictionary. It has 13,000 entries in the knowledge base. And for evaluation, I would like to report that Lunar was able to answer correctly 78% of the sentences that humans, actual professional geologists, wanted to ask of that system. And this happened a long time ago, back in 1971 at the Lunar Rocks Conference. So here's some of the sample questions that Lunar was able to answer. How many Brexias contain olivine, and what are they? So those are specific questions about the rocks that were in the collection. So just to give an idea what an ATN looks like, this is a snapshot from the Bill Woods paper from 1972. You can see that you cannot really read the fonts, but you can get an idea that this is a fairly complicated finite state automaton that is used to represent the user's questions. So the next system that I want to mention today is Sherdlu by Terry Winograd. It was designed to answer questions about the blocks world. Here's a simple example. The blocks world at that point in time was rendered as those kind of meshes of lines. There is a box on the right-hand side, and there are a lot of blocks in the form of pyramids and cubes and other shapes that were either in or outside of the box, possibly on top of each other. So the system simulated a robot that was able to recognize some of those shapes and be able to place them on top of each other, move them into the box, or remove them from the box. So here's a sample dialogue. The person says, pick up a big red block. And the system says, okay. So that means that it understood correctly that there is only one big red block available, and it was able to find it and move it. The next thing that the person says is, grasp the pyramid. Now the computer says, I don't understand which pyramid you mean. So in the context of this dialogue, there may be multiple pyramids, and the computer needs a little bit more context. So the person now says, okay, forget about this pyramid. Now find a block which is taller than the one that you're holding and put it in the box. So as you can see here, the questions involve commands, but also inference. So the system has to be able to identify all the blocks that are in the world to figure out which ones are taller than the ones that it is holding, and then determine if this is unambiguous, and if it isn't unambiguous, to actually perform the action and move that block to the box. So here's what the computer says. By it, I assume you mean the block which is taller than the one that I'm holding. And that's just a confirmation that the computer understands what the person was asking. And then the computer goes on and says, okay. So that's exactly what I'm going to do. And by saying okay, the computer performs the action that the person intended. Then the person asks, what does the box contain? And now the computer says, well, the box contains the blue pyramid and the blue block. So it has a very good representation of the world at any point in time, what it is holding, what's on the surface, what is on top of another block, what's in the box, what's outside of the box, and so on. And now the last question is, what is the pyramid supported by? The box. What that means is that the box contains the blue pyramid and the blue block, but the blue pyramid is not on top of the blue block. Instead, it is directly sitting on top of the box. How many blocks are not in the box? 4 of them. Is at least one of them narrower than the one which I told you to pick up? Yes, the red cube, and so on. If you're interested in this system in a little bit more detail, you can go to the official website where there are many other transcripts and also simulation software that lets you manipulate the blocks world with a little bit better graphics than the ones that were used 40 years ago. So the next system that I want to discuss today is called START. Here's what it looks like currently. It allows you to ask arbitrary natural language questions, and it keeps some of the most interesting ones in a log, so you can look at the questions in the category geography or science and reference, and so on that have been asked in the past. So START is an open domain system, unlike, for example, Lunar and SharedLoo, which were about very specific domains. It uses the web as the backend and has been mostly continuously online since 1993. So that makes it the oldest web-based system out there. So this is a little bit of introduction about question answering system. We're going to continue with the next set of examples in the next section.